Problem 11. Which tile must be added to the pictures so that the total light area is as large as the total dark area? We have to find out this missing tile. And these are our options. Let's break this problem into step by step and use method of elimination. We will walk through each block, match them, and then eliminate them if they match. As we do this, we can eliminate option where the light and dark areas are already balanced. First, we find a block where the full light area balances with the full dark area. So we don't need this. Similarly, we matches full dark area with full lighter area. We eliminate it. Next, we move down and see there is a half painted block. It balances with itself. We eliminated it. Similarly, this is a half painted. We eliminate it. This is half painted as well. We eliminate it. Now the lighter colored block has no match, leaving us with option B, that is a darker area. And this is our answer. Awesome. We solved it with the method of elimination again. Let's move on to problem 12. Mary had equal numbers of white, black, and striped tokens. She used some of the tokens to make the pile shown in the figure. She still have 5 tokens which are not in the pile. How many black tokens did she have in total? Mary started with equal number of white, black, and striped tokens. The pile in the figure is made up of some of these tokens, and we need to figure out how many black tokens Mary had in total. First, let's look at the pile. We see there are 1, 2, 3, 4, and 5 black tokens. We see there are 4 white tokens, and then there are 4 striped. We add them and that makes 13 tokens shown in this figure. We know that Mary still have 5 tokens left. So the total number of the tokens she initially had, that is 13 plus 5, gives us 18 total tokens in total. Since Mary had equal number of white, black, and striped tokens, we divide. So we divide 18 divided by 3 gives us 6 tokens of each color. Therefore, Mary had 6 black tokens in total. So our answer is option B. Awesome. Every problem you solve makes you smarter and sharper. Keep going and never stop challenging yourself. We are doing problem 13 now. Problem 13. The solid in the picture was made by sticking 8 equal cubes together. What does this solid look like when seen from above? We need to figure out what this solid would look like when seen from above. Let's visualize it. First, imagine 3 blocks in a row and there are 2 blocks parallel to it. Any picture which resembles this would be our answer. So let's move on to looking at option A. We see that there are 3 blocks in row, but there is none in here. So that is incorrect. We moved on to option B. We see that there are 3 in there, but there are no 2 parallel blocks. So we remove option B. We moved on to option C. We see there are 3 blocks in row and then there are 2 blocks in parallel. This could be our answer. We moved on option D. We see that we have 3 blocks in row, but there are only 1 eliminated. E option, we see we have 3 blocks in a row, but there are no 2 blocks in parallel. So we eliminate it. So our correct answer is option C. This was another visual problem and we solved it. Let's move on to problem 14. Problem 14. On planet Kangaroo, each Kang year has 20 Kang months and each Kang month has 6 Kang weeks. How many Kang weeks are there in 1/4 of a Kang year? These are our options. Let us break down this problem into step by step. First, we need to understand the information given to us. We know 1 Kang year is equal to 20 Kang months. We also know 1 Kang month is equal to 6 Kang weeks. Now we have to find out how many Kang weeks are in 1 Kang year. Let us go deeper into it. We know Kang year. We know 1 Kang year is equal to 20 Kang months. We have Kang weeks. We know 1 Kang months is equal to 6 Kang weeks. Now we have to convert Kang weeks into Kang year. That means smaller unit to a bigger unit and we multiply. So to determine Kang weeks in 1 Kang year is 20 into 6 gives us 120. Now we have to find out how many Kang weeks are in 1/4 of a Kang year. Since 1/4 is a fourth of something, we multiply 1/4 of a Kang year. Kang weeks in 1/4 of a Kang year is 120 multiply 1 by 4 gives us 30. So our answer, there are 30 Kang weeks in 1/4 of a Kang year. So the correct answer is option B, 30. We have reached the final question of this series, problem 15. Great job, follow along and solve these problems with me. Problem 15. Nick has written each of the numbers from 1 to 9 in the cells of the 3 by 3 tables. Only 4 of these numbers can be seen in the figure. That is 1, 2, 4 and 3. Nick has noticed that for the number 5, the sum of the numbers in the neighboring cells equals 13. Neighboring cells are the cells sharing a side. He noticed the same applies to the number 6. Which number has Nick written in the shaded cell? So we have to find the number written in this shaded cell. So what is our clue? Our clue is the number next to the 5. That is, if the 5 comes in here, then this number should sum up to 13. And similarly, if there is a 6 number coming up, then the sum would be 4 plus some number here plus 3 should give us 13. So let's solve it together. First, we sum up the neighboring numbers given to us. So we sum up 1 plus 4 gives us 5, 1 plus 2 gives us 3, 2 plus 3 gives us 5, and 4 plus 3 gives us 7. Now we notice that these two numbers are similar. So how far they are from 13? So let's see. 13 minus 5 gives us 8. So if 8 is the common number here, then see, and if 5 or 6 comes on this location, then 1 plus 8 plus 4 gives us 13. That's true. Then 2 plus 8 plus 3 gives us 13. So if either 6 comes here, or 5 comes here or here, the central number remains 8. That is our answer. So option D is our answer. Awesome work. You have tackled all the problems like a true champion. This wraps up our challenge for today, but don't go anywhere. There is more fun and exciting math coming up your way. We will be solving problems 16 to 20 next. Make sure to like, subscribe, and hit that bell so you never miss a new challenge. See you in the next problem solving adventure. Thank you.